Dear students, today in this lecture from the topic applications of derivatives, we will study the new application, that is, see here, maxima and minima. In last lecture we have completed the increasing and decreasing functions, the exercise number 4.2. Today we are going to study the maxima and minima. So let us see. Now see, maxima and minima means what? Maximum value and minimum value of the function. So let us see the definition of maximum value of f of x. Now maximum value of f of x means what? A function f of x is said to have a maximum value at a point x is equal to c if f of x is less than f of c for all x not equal to c. Means you will get a one point at which the function attains a maximum value. Means suppose at point x is equal to c, if you have f of c as a maximum value, then other than point c you will get all the values of f of x which are less than f of c. F of c is maximum, so that's why the value f of c is called as the maximum value of f of x. So see this carefully. Now thus we can say that the function f of x will have a maximum value at x is equal to c if f of x is increasing for x less than c and f of x is decreasing for x greater than c, as shown in this figure. So see here, in this figure there is a point c on the x-axis at which function attains a maximum value. So in that graph it is shown as c comma f of c is the point at which function attains a maximum value. Okay, and in the neighborhood of c means what? C minus delta. Here it is given as c minus delta, where delta is very small positive number, means all the values before c, so that can be written as x less than c. So all are increasing values here. At the point, exactly at point c, you will get the maximum value, and after that the values are decreasing. When x is greater than c, see, graph shows that the values are decreasing values. Okay, so see here, from the graph you will understand that at point x is equal to c, function attains a maximum value. So this is the definition of maximum value. Now similarly we will define the minimum value of the function. So let us see. Now what is the meaning of minimum value? A function f of x is said to have a minimum value at a point x is equal to c if f of x is greater than f of c for all x not equal to c. Means at point x is equal to c, we get the minimum values. See here, it is shown in this figure, and other than c, for all that points the f of x is always greater than f of c, so we get the f of c as a minimum value. So in the neighborhood of c, means before c, the function is decreasing, and after c the function is increasing. So you will get at point x is equal to c, you will get the minimum value of this function. So from the graph you will clearly understand that, see, the value of f of c is called the minimum value of f of x, and the function will have a minimum at x is equal to c if f of x is decreasing for x less than c and f of x is increasing for x greater than c, as shown in this figure. Okay, so let us see here. In this figure, function is decreasing here like this, and after the point c the function is increasing like this. Okay, here it is decreasing, and then after c it is increasing function. So exactly at point c the function attains a minimum value. Now this is the graphical approach to get the maximum and minimum value of the function. But with the help of applications of derivative, we have to find out the maximum or minimum value of the function. So that we will study now. So this is the graphical explanation to get the idea about the maximum and minimum value of the function. So let us see now. Now how will you get the maximum and minimum value of the function with the help of applications of derivative? So there is a procedure given for you. It is called as second derivative test. Okay. So what is the procedure? See here. A function y is equal to f of x is said to have local maximum at x is equal to c. Local maximum means for the particular interval. If you have the maximum value at point x is equal to c, if, when it is possible, if f dash of c is equal to 0, means derivative at the point x is equal to c is 0, and f double dash of c is less than 0, means second order derivative at that particular point is less than 0, then we can say that function attains a local minimum value at x is equal to c. By example we will clear this idea, but just see the second derivative test. Okay. Now in case of minimum value, a function y is equal to f of x is said to have a local minimum at x is equal to c if f dash of c is equal to 0 and f double dash of c, means second order derivative at that particular point, must be greater than 0. So we will follow the procedure of finding maxima and minima with the help of second derivative test. Okay. So now let us see the exercise which is given for you. Exercise 4.3, in which question number 1, that is determine the maximum and minimum values of the following functions, and 3 functions are given to you. Now we will solve first 2 functions to get the maximum and minimum values in this lecture. Okay, so you will get the clear idea about the second derivative test. So let us see now. Now first function which is given to you, that is f of x is equal to 2x cube minus 21x square plus 36x minus 20. Now in answer, first of all we will write the given function. Okay, see the procedure now directly by example, then you will get the idea about that second order derivative test. Okay, so what is the procedure? First of all we have to find out the derivatives, first order derivative. So we have to differentiate the given function with respect to x. So we get f dash x. Okay, so see the derivative here, 6x square minus 42x plus 36. Check this derivative, and again you differentiate with respect to x, so that you will get the second order derivative, because we also need the second order derivative. Okay, so f double dash of x, that is here 12x minus 42. Now first order derivative and second order derivative are completed. Now as per the second order derivative test, first of all we have to consider that f dash of x is equal to 0. Okay, so let us see now. So we get 6x square minus 42x plus 36 is equal to 0. Now if you observe this quadratic equation, then you can divide it by 6, and hence you will get x square minus 7x plus 6 is equal to 0. Now just you solve this equation by splitting the middle term, and then you will get the values of x here. So see, x square minus 6x minus x plus 6 is equal to 0. Split the middle term like this. Now take common. X is common from the first two terms, then from second two terms you will get minus 1 common and in bracket x minus 6 which is equal to 0. So hence you will get x minus 1 into x minus 6 is equal to 0, from which you can say that x minus 1 is equal to 0 or x minus 6 is equal to 0. Okay. Now from this you will get the values of x. X is equal to 1 or x is equal to 6. So just after finding the derivatives, first order derivative and second order derivative, first of all you have to consider the first order derivative equal to 0, solve that equation and get the values of x. These are called as extreme values. Extreme values means what? At this point, means x is equal to 1 and x is equal to c. At this point you will get the maximum and minimum value of the function. So these are called as extreme values of the function. Now we have to check the second order derivative when x is equal to 1. So check the second order derivative. So f double dash of 1 is equal to 12 into 1 minus 32. Now by calculation you will get here minus 20, which is less than 0. Now by second derivative test, what is your conclusion here? By second derivative test, if the second order derivative is negative, then f of x attains maximum value at x is equal to 1. This is our conclusion. Okay, remember this conclusion to understand the second derivative test. What we have written here, f of x attains maximum value at x is equal to 1. So we get the point at which function attains a maximum value. Now what is the maximum value? How will you get that? So maximum value is equal to, you have to put x is equal to 1 in the given function. So it will be f of 1 will be the maximum value. So in the given function just you put x is equal to 1 and then by calculation you will get the maximum value. So see the calculation here carefully. Okay, so this is 2 minus 21 plus 36 minus 20. So that's why this is minus 19 plus, here you will get 36 minus 20 means 16. So that's why you will get minus 3. Okay, so this is called as the maximum value of the given function. Okay, minus 3 is the maximum value of the function at point x is equal to 1. Okay, now we have to check when x is equal to 6, at point x is equal to 6, we have to check the second order derivative. So that is f double dash of 6. So 12 into 6 minus 42. Okay, so here you will get 72 minus 42. That's why you will get plus 30, which is greater than 0. Okay, sorry, here I have to take 42. See here 42. So that's why here you get minus 30, but it is negative, so no problem. So hence at point x is equal to 1, you will get the maximum value. Okay, I will correct this, 12 minus 42. Okay, now here in this case at point x is equal to 6, we get 12 into 6 minus 42, that is equal to 72 minus 42 is equal to 30, which is greater than 0. So as the second order derivative is positive, we can say that f of x attains minimum value at x is equal to 6. So what will be the minimum value here? So minimum value, that is equal to f of 6. Now we have to put the value of x as 6 in the given function. So that's why you will get 2 into 6 cube minus 21 into 6 square plus 36 into 6 minus 20. Okay. Now see this calculation. Now see the calculation. This is 2 into 6 cube is 216 minus this is 21 into 36 plus 36 into 6 is 216 minus 20. Now further if you solve, then 2 into 216 is equal to 432. Check this. Minus 21 into 36 is 756 plus this is 216 minus 20. Now if you see this calculation carefully, then you will get the last answer as minus 128. Check this. Okay. Now this is called as minimum value of the function. So what is our final answer now? The answer is, if you want to write the last answer, then maximum value is equal to what? It is equal to minus 3 at point x is equal to 1, and minimum value is minus 128 at point x is equal to 6. So see, with the help of second derivative test, how to get the maximum and minimum value of the function. So this is the detailed procedure by which you will get maximum and minimum value of the function at a particular point. Okay, always remember, you have to take the first order derivative equal to 0. You will get sometimes you will get only one value of x, two values of x, or three values of x. For every value of x, you have to check the second order derivative, and then you have to confirm that whether the maximum value exists or minimum value exists at a particular point. Okay. Now see, another function is given that f of x is equal to x into log x. You have to find out maximum and minimum value of this function. So first of all, write down the given function, that is x into log x. Now differentiate this with respect to x. So differentiate with respect to x. Then you will get f dash x. Now take the derivative of x into log x. You have to use u into v rule. So x as it is into derivative of log x is 1 upon x plus log x as it is into derivative of x is 1. So in short, you will get 1 plus log x, because x into 1 upon x is 1. So this is the first order derivative. Okay. Now take the another derivative. So differentiate again with respect to x. Then you will get f double dash of x. Now you have to take the derivative of 1 plus log x. Derivative of 1 is 0 plus derivative of log x is 1 upon x. Now what is our procedure? We have to consider that f dash x is equal to 0. So here in this case it is 1 plus log x is equal to 0. That means what? You will get log x is equal to minus 1. Now we have to solve this equation to get the value of x. Now we know that logarithmic and exponential form of the given term. So here log x is equal to minus 1. Base is by default it is e, and if you convert this logarithmic form to exponential form, then you will get x is equal to e raised to minus 1. Since we know that log a to the base b is equal to x, then you will get a is equal to b raised to x. See the relation between the exponential and logarithmic form. This is the logarithmic form. And how will you get the exponential form? That is a is equal to b raised to x. So by this relation we get x is equal to e raised to minus 1. If log x is equal to minus 1, then you will get x is equal to e raised to minus 1. That means we get x is equal to 1 upon e. We get only one point here. Okay. Now when x is equal to 1 upon e, we have to check the second order derivative, that is f double dash of 1 upon e. See here. Now f double dash of x is 1 upon x. So f double dash of 1 upon e is what? 1 upon 1 upon e. That is equal to e. And e is a positive real number. So e is greater than 0. So what is our conclusion? So f of x attains minimum value. See here carefully. Minimum value when x is equal to 1 upon e. Means at point x is equal to 1 upon e, we have checked that second order derivative is positive. So that's why we know that f of x attains minimum value when x is equal to 1 upon e. Now what is the minimum value of this function? So minimum value is equal to f of 1 upon e. Means for the given function we have to find out the minimum value at which point? At x is equal to 1 upon e. So the function is given x into log x. Just put the value here. So it is 1 upon e into log of 1 upon e. Now see how will you simplify this? So that is 1 upon e into, this is log of e raised to minus 1. And hence it can be written as minus 1 upon e into log e. Just you take the index here by logarithmic rule and you will get minus of 1 upon e into log e. That means now as you know that log e is always 1, we get minus 1 upon e. And this is the minimum value of the given function. Okay. Now for this function, maximum value does not exist because you get one point at which the function attains the minimum value only. So sometimes in some functions where sometimes a minimum value exists but maximum value does not exist. Sometimes it happens that maximum value exists but minimum value does not exist, like that. So you have to consider as per the given information or given function. So what is our last answer? You can write last answer, f of x has minimum value, f of x has minimum value that is equal to minus 1 upon e, and at point x is equal to 1 upon e. So this is our last answer. So see this carefully, how to get the minimum value or maximum value of the given function. Thank you.